Today we are going to discuss computer fundamentals, hardware part 1. So what we are going to discuss is the hardware of a computer at a basic level. So let us get started. So this is a simple computer and this is an old computer. So what we have here is what is called keyboard, and this is the monitor. Then you have speaker, then you have a mouse, and then you have a tower unit. So tower unit houses the main part of the computer. So what is there in the tower unit? So before that, what we just saw was the monitor, and we saw the keyboard. So these are the hardwares, external hardwares, mouse, printer, etc. There can be scanner and other kinds of hardware. So the tower unit contains what is called the motherboard. So this is the most important part of the computer, and this is how it looks like. So the most important is the processor slot. This is where the CPU sits. And then you have memory slots. This is where the RAM sits. Then you have IDE slots, integrated device electronics drive. So this is where the hard drive sits. Okay. Then you have power connection of course. Then you have AGP slot. So we have PCI slot, principal component interface slots. So this is where these are the slots where you put your sound card, graphics card, etc. And this is the AGP slot. So AGP slot is accelerated graphics port. So we'll come across these jargons in detail later on. So what do they mean? This is what the motherboard looks like. So this is a printed circuit board. This is important. So this is a printed circuit board. Printed. This is what is called a printed circuit board. Okay, this is what is called a printed circuit board. And this is what it looks like. So what we saw in the previous diagram, this is what it looks like, and these what you see the lines, these are the connections. You can see the wire traces of the motherboard. This is a complicated stuff, and so let us see what we discussed, what we saw in the previous slide. So we saw the processor slot. This is where the central processing unit sits. Okay. Then we have PCI, which is called the peripheral component interface. This is the place where the graphics card or sound card, etc. sits. So card is something kind of it contains various, like it's a kind of independent circuitry. Then you have memory slots. So memory slots is where a very important card sits, which is called the RAM, which is known as the random access memory. We'll come across it soon. And then we have the IDE slots where the hard drive sits. So what is a hard drive? That also we'll see. So what we saw here, this picture has CPU, then you have North bridge, South bridge chips, you have RAM, there you have hard drive or SSD, we have SMPS, we have peripherals, we have ROM, we have optical drive, and CMOS. All these things are assembled or situated in this motherboard. So this is what a CPU looks like, a typical CPU. And what is this? So one sec, okay. And this is North Bridge, South Bridge chips. So these are also important chips. So North Bridge chip, so this is my CPU. So it regulates, the CPU is the, we see CPU is the main component of the motherboard, and this North Bridge chip regulates very fast processes like high speed graphics, then memory slots. These are all connected to the CPU through the North Bridge. And then slower processes, okay, like in this PCI, which may contain sound card and etc. Slower processes or ROM, they are regulated by the CPU through what is called the South Bridge. Okay, so we have North Bridge and we have the South Bridge. So a very important component of a computer we have come across is called what is called a RAM. This is what a RAM card looks like. So this is random access memory. And then you have a hard drive. So this hard drive looks like, so the internal computer hard drive. So this is the casing. So inside is the hard drive. Hard drive is situated inside. And what is, so inside you have a hard drive which is situated. Nowadays we don't use this kind of hard drive. What we use is this kind of SSD hard drive, solid state device. And here you have a typical SSD hard drive. Is NMVE type hard drive which has no moving parts. Here we have a moving part, because here what we have is inside we have is a spinning, we have a spinning magnetic disk. So that is a moving part. But instead of this kind of hard drive, we are now using SSDs. And this is the power supply unit, SMPS, with a fan to cool the CPU. And this is the peripherals. The peripherals means this is a typical graphics card. What we are seeing here is a graphics card. You can have sound card, Ethernet card, etc. So now we go into the stuff in slide details. So what we have here is a central processing unit, CPU, central processing unit. So this is called the brain of the computer. The CPU regulates everything inside the computer, how the input data is converted into output information. It stores, executes program instructions through its vast network of circuitry. It controls all the internal functions like allocating computing resources, interfacing with various programs, etc. So it does almost everything that a computer is supposed to do. So that's why it's called the brain of the computer. So what is written here we may not be able to appreciate right now, but as we progress we will see what all these things mean. A very important concept in computer is a memory cell. Okay, this is a memory cell. So I have just drawn a schematic diagram of a memory cell. So what does the memory cell actually do? So there will be an input. There will be an input here. So the input has to be written to the memory cell. So there will be some mechanism through which this input will be written into the memory cell. So fine, once it's written, at some point of time we may want to see what is there in the memory cell, what information. So there has to be a mechanism to read that input. and once we read it, it will be sent as an output to some other system or register. So this output will become input of some other register, and we'll see what register is later on. So here we have C, memory cell. The basic unit in computer where information is stored in bits 0 or 1. So we know that computer understands only binary, either 0 or 1, nothing in between. Okay, so it's either 0 or 1. So the input information will either be 0 or 1, and so the input is done. So then we have write. Write means using some process the input information is written in the cell. Read, using some process the stored information that we had written when we require it, that's stored information in the cell is read. And also there has to be a mechanism for that. And then we have output. The information that has been read is sent to another unit for processing. This is what a memory cell does. And what is a memory cell? Memory cell is a circuitry which will store the information. So we now come to what is called a random RAM. You have frequently come across this, what is the RAM of this computer, or what is the RAM of a mobile. A mobile is a kind of computer. And random access memory, so this is called the main memory of the computer. Main memory of the computer is RAM. So it is made up of ICs, integrated circuits, which contain memory cells used as main memory of the computer. The cells are made up of transistors and capacitors to store the bits. So what I had initially told that is just a memory cell, it was a black box for us. For RAM, this memory cell is typically made up of transistor and capacitor. For other types of for other types of electronic units, it may be made of something else. But for say the RAM, it may be it's made up of say transistors and capacitors. It is a short time memory. The processor needs to carry out its function when running various applications of the computer. It is a volatile memory, that is, data is stored only for a short time and is erased if the power is switched off. The capacity of a RAM is generally defined by how many bytes it can store. So you have heard of 4 gigabyte RAM, 8 gigabyte RAM, 16 gigabyte RAM, etc. So like 4 gigabyte means 4 times it could be, I think, 10 to the power 9 bytes. Okay, so many bytes, and 1 byte is 8 bits. So it's like this. So what does it mean? So it needs, it's need to carry out functions when running various applications of the computer. So when you're running various applications of the computer, or the computer is running a program, then it needs to access some information very fast. So those informations are stored in the RAM, so that RAM can be accessed very fast. So, and it's a volatile memory. Volatile memory means data is only stored for a short time, and if you switch off the computer, all the information is lost in the RAM. But RAM is the most important part of the computer when it's running. because it helps in storing applications or informations related to the applications which the computer needs while running the application. Okay, so this is a typical RAM, and RAM can be of two types. One is called a DRAM, which is the dynamic RAM. This type of high density, that is high data storing capacity RAM, is used as the main memory. It has to be frequently recharged as there is leakage of charge from the capacitors. So this kind of RAM is made of capacitors and transistors, I told you. So this is called DRAM, and since there is leakage of charge from the capacitor, this kind of RAM has to be frequently refreshed or recharged. Okay, so but the important thing about this kind of RAM is that it is high density. It has high data storing capacity. So this is dynamic RAM, which is what is shown here. So this is DRAM. Another kind of RAM is SRAM. This is type of low density RAM. Low density means it may not be able to store, it does not have high data storing capacity. But it has an advantage. It is used as cache memory and high speed registers. We'll come to registers later on. And important thing about this RAM is there is no leakage of such charge as RAM, as it is made up of flip-flops. It is not made of capacitors, it is made of flip-flops. So this kind of SRAM doesn't need any kind of charging from time to time. That's why this kind of SRAM is fast to access, even faster than DRAM. But problem is that it cannot store lot of data, whereas DRAM can store lot of data. And so the main memory is of the computer is a DRAM, while SRAM is used in cache memory and high speed registers. Next we come to HDD, hard disk drive. So this is a storage device that is used in desktop computers and laptops. Data in the HDD remains safely stored even if there is no power. So this is the difference. This is a main difference between HDD and RAM. So this is a non-volatile device. So even if you switch off the power, the data that is stored in the hard disk drive remains there. It's not lost. It is there forever, unless and until you remove it deliberately. Whereas your RAM is volatile. So if you switch off the power, everything is lost. But RAM helps in calculations. So when you are doing writing programs or executing programs or executing some application, RAM is being constantly used by the computer, because all the data that is required during the calculations or running the application is there in the RAM. So HDD is it's a magnetic spinning device. I told you, with an arm that is called the actuator that reads and writes. So how does it store information? The bits are stored in magnetic cells. So this spinning device has many magnetic cells, and information or bits are stored in the form of magnetization of a cell. If its magnetization is up, then it is called 0 state, and if the magnetization is down, it is called the 1 state. So that is how information is stored in a hard disk drive. So this is my hard disk drive. So this is my actuator. This is the part. So this is the part that is. So this is the part that reads and writes information on this spinning disk. So this is the disk that is spinning. It's a magnetic disk and it is spinning very fast. And the actuator actually moves along this disk where it wants to go and reads or writes the information and sends it. So this is called also called the secondary memory. The main memory is the RAM. So nowadays we don't use HDDs. We use something more sophisticated, and that is the solid state drive, SSDs. Though this is a secondary memory like HDD that stores information bits and is non-volatile in nature. That is, once you store data in SSD, it is there forever. But why is it better than solid state? Why is it better than HDD? Because unlike HDD, it has no moving parts, and the information can be written and retrieved fast compared to HDD. So whatever information is there in the SSD, it can be retrieved fast by the computer compared to HDD. And HDD is slower and it's bulky and it takes a lot of power because it's a spinning device. So SSD also consumes much less power than HDD. So what is the working principle of SSD? The SSD uses NAND based flash memory for storing bits using floating gate transistors, which can store electronic charge forever unless the charge is forcibly expelled. Unless the charge is forcibly expelled. The SSD has a controller which processes the flow of data between the computer and the NAND flash. So what is this SSD? SSD is actually composed, it is a MOSFET. SSD is a MOSFET. If you don't know, then you don't have to worry. Metal oxide semiconductor field effect transistor. It's a MOSFET, but it has something called, it's a MOSFET but with additional layer what is called the floating gate. It has what is called a floating gate, and this floating gate can be in two states. Either it contains charge or it contains no charge. It contains no charge. No charge is what we call the zero state. And this is the no charge is the 1. Like down magnetization was 1, here no charge is considered the state 1, and if it is charged it is called the zero state. So here charge determines the state, whereas in hard disk drive it was magnetization that determined the state 0 or 1. Here it is the charge that determines the state 0 or 1. and that is done through what is called a floating gate. So in MOSFET, you build another additional gate, what is called a floating gate, and the floating gate can contain charge, then it's a zero state, and if you expel the charge from the floating gate, then you go to the state 1. Or if the floating gate does not have any charge, it is in state 1, and you introduce a put charge in the floating gate, then you go to the state from 1, you go to state 0. And you can be in the state 0 or state 1 unless and until you forcibly change the state. So this kind of MOSFET with floating gate is what is called NAND based flash memory, for using which can store electronic charge forever unless the charge is expelled forcibly. So the SSD controller determines if the SSD controller has a controller, if determines that some particular data is being used frequently, then it stores the data temporarily in a cache called DRAM. Just like in RAM we use DRAM, SSD also uses a kind of cache, so that information which is being frequently used by the user is stored in the DRAM so that it can be fetched quickly. So this is what SSD looks like. So this is what we are having this, what we have, these are the flash cells. Okay, so these memory cells are flash cells which are made up of MOSFET with a floating gate. Okay, and then you have the DRAM. If some information or data is being frequently used by the user, then this data is temporarily stored in the DRAM. And all these things are controlled by what is called the SSD controller. This is the SSD controller. It is controlling everything on this board, and it is connected to the motherboard, what is called SATA. So what is SATA? SATA is Serial Advanced Technology Attachment. So what is SATA? It is a computer bus. Bus is a term that is frequently used in computer terminology. Like bus takes us from one place to another. This bus means a sort of communication. So this computer bus is used. So this is a bus, is again electronic circuitry. So it is a computer bus to connect the hard drive to motherboard. So this is an advanced. So earlier we had ATA. So this is more advanced, this is faster. So it is a computer bus to connect the hard drive to motherboard. And a computer bus, a bus can be various types. So it is basically a communication system that connects the various components of the computer to the motherboard. Today we're going to end here, and we will start with the second part very soon. So thank you.